Okay, so we're going to talk about determining a maximum area when there is a fixed perimeter. This is a phase of optimization. So optimizing basically means finding the best values or dimensions for your shape. So in this case, we're looking for the largest area when the perimeter has to be a certain value. So our question says, determine the maximum area of a rectangle with a perimeter of 24 meters. So let's refresh those formulas we need. We need perimeter equals twice the length plus twice the width. We need area equals length times width. Okay? And we're going to do this with a table with the width, the length, the perimeter, and the area. So now I'm changing two variables at once. I'm changing both the width and the length. And in order to do that, the table lets us do that in a systematic manner. So the one that I'm going to change is going to be the width, okay? And the width is going to determine the length. In this case, we know that the perimeter equals 24. So if my perimeter equals 24, how do I find length? Well, let's look at this 2L plus 2W equals 24. And I want to isolate for L, so using our algebra. So I'm going to have 2L equals 24 minus 2W, and L equals 24 minus 2W, all divided by 2. Okay, so note that formula. That's the formula that we're going to use. So in this case, width is 1. So if width is 1, then length is 24 minus 2 times 1, so that's 2. 22 divided by 2, that means the length is going to be 11. Okay? If I put 1 and 11 into my perimeter formula, I find the perimeter is 24, which matches what I need in the question. And then how do I find area? I multiply 1 times 11 is 11. Okay, try it again. So width is 2. If width is 2, I use my formula, and I find that the length is 10. It's still going to give me a perimeter of 24, and then the area is going to be 2 times 10, which is 20. And I'm just going to keep going. That could be 24. 4 times 8 is 32. 5, that's going to be 7. Still gives me 24. 5 times 7 is 35. 6 gives me 6. 24. 36. 7. 5. 24. 35. Okay? So look at what we've discovered. We've discovered that a length of 6 and a width of 6 gives us our maximum area. And that happens a lot when we're looking at rectangles that have all 4 sides. The maximum area is where the dimensions are as close to equal as possible. So in this case, the answer would be, okay, I'm going to write the answer right here. The answer would be the dimensions are 6 by 6 for an area of 24, sorry guys, for an area, yeah, of 36 meters squared, okay? So notice the perimeter always stayed the same. We have a fixed perimeter, that means it's not changing. We used our perimeter formula to determine our length values when we changed the width. We used that to then calculate the area to find our answer. Now what I did is I just went as far as I could until, you see these are all increasing, and then they started decreasing again. That's how I know I found it. If you just keep going, 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 and it keeps going up, 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 you're not at the end. You need to see your area start to decrease again, and then you found the turning point where you hit the maximum.